Hey guys, this video is going to help you understand the law of conservation of mass assignment that is on Schoology. So real quick, the instructions say that you're going to answer the questions. You get 3 attempts to do the best that you can. After you answer the questions on this first page, make sure you go to the next page to do the exit ticket. So let's start here at the top looking at the reading here. So you have probably already uh, understand this from experiences somewhere in your life is that the law of conservation of mass says simply that when you do a chemical reaction, the total weight that you make will be the same as the ingredients you started with. So the stuff that you start your chemical reaction with must be the same as what you end with. Now, a really good way to think about this is cooking. Cooking is you don't think about it being chemistry, but it is chemistry you can eat. It's science you can eat. So this example of a pizza here is you can start with a raw pizza that has all those toppings on it, and when you weigh it, it'll weigh one weight. And then when you cook it, it'll come out weighing something less. So like here it says you'll end up with something like 670 grams, which is different from the 700 grams you started with. There's 30 grams missing. All right. So you might be missing it because like things drip off. There's moisture in the crust that evaporates. Some sort of accidental error in chemical reaction that seems like it doesn't follow this law that we learned. So it's weird to think about because our brains don't see this stuff happening. You don't see the moisture evaporating. We really have a hard time grasping that air, something that's invisible, actually weighs something. It has a mass. You can actually physically measure it. It's just a little difficult, but it's possible. So here below is this equation. We talked about it in one of the warm-ups. So what we're going to do is we do something called balancing, and we're going to work on this later, but we're going to do something called balancing where you will fix this misunderstanding of mass by altering the amounts of each atom. Now, when you balance it, you're not actually saying, I'm going to add more of this than that. You're fixing it so you find the true form of the equation. Now, we're going to talk about that a lot more later, and that was a very quick glossed over answer of what balancing an equation is, but it's just to make sure that you have the same atoms before the reaction and after. So when you look at this chart here, you can see that on the left side of the arrow, the reactants is that it is not the same as the products on the right. So you would be like, wait a minute, I'm missing an oxygen. Okay, these oxygens don't add up. I'm missing something. Something is wrong. All right, so as you can see, there are 2 atoms of hydrogen on the left and 2 oxygens, which is not equal to what's on the right. All right, so we're going to learn how to do this by balancing equations, which we're going to learn next. All right, so that's kind of the introduction to balancing. So when you get down here, there's this video. It's about 5 minutes long. I'm not going to watch it on this video because this is a walkthrough. So when you do this assignment, make sure you watch this video because the next 2 questions come straight from the video. All right, so watch it. It talks about the law of conservation and what that means for us in real life, and it gives you some examples. So as you keep going, the law of conservation only happens in an open or a closed system. You should hear that in the video a lot, that it's only true in one of these. An open system is a system that is not contained. And a closed system is like what we did with the chemistry in the Ziploc bag lab we did, where you poured the water in the bag and you sealed it up. Or if you noticed in the chemical reaction I did on the Nearpod yesterday, I quickly put a cork on top and I had a balloon hooked up to the tube. That way, nothing escaped. So that's called a closed system. So it makes sense when you think about it, open and closed. All right, so in this cartoon, all right, this might I realized when I asked a few students about this question is that None of you guys were alive in 1990, so it might be a little bit hard to understand, and you might not have been born yet. So back in the 90s and early times, TVs used to be huge, like 200 pounds plus. My parents used to have a TV that was no joke, 200 pounds. And I know that because I picked it up and I had to move it. It was not easy to do because nowadays every TV you see is flat, it's light, they're like under 50 pounds and anybody can move them. And you mount them on the wall. It never used to be like that. So if the total mass of the TV and the human in 1990, all right, was most the TV was heavier than the human, all right, what happened to the mass of the TV and the human here? All right, so the mass didn't change, but something else did. All right, so that's what I'm saying. So you want to think, I want you to think about the law of conservation we just talked about up top, that matter cannot be created or destroyed. How does that apply to this TV? Okay, give that a try. It's a cartoon. It's meant to be kind of silly. So um, talk about the mass in relation to the TV and the human. Down here is a fill in the blank. It's a fill in the blank directly from this quote, which I just said. All right, so make sure you are paying attention and you can fill in the blanks based on the definition. All right, this one, you're doing the mass measurements of the pizza and the cheese. And then down here, this is that warm up again. Okay, so I'm basically giving you a free answer here. I'm making you see what the difference is on each side of the reaction and where the misconnect is. All right, and then you're going to talk about the weight of the pizza and why when you put it in the oven, it will weigh less. All right, when you get to the exit ticket, here they are. Make sure you're paying attention to these because they are a little bit wordy, but you should be able to answer them based on what we did. This one, number 11 especially. Okay, so you will need to read this question carefully. If you have two chemicals, chemical A and B, you will react together in an experiment. Chemical A has a mass of 4 grams and chemical B has a mass of 8 grams. When you mix them together and they react completely, you will make new chemicals, C and D. So if the reaction of the mass of C is 5, how many grams of D is produced? So A and B, all right, so chemical A weighs 4 grams, chemical B weighs 8 grams. After the reaction, chemical C now weighs 5 grams. What is the mass of D? All right, so think about the products have to equal the mass of the reactants. That's the key there. All right, and then you submit. You get about 3 attempts at this. You do get 3 attempts at this based on the instructions, and I will try to grade them as fast as possible so you can get an accurate understanding on what your score is. If you need help, come show up to my office hours, and I'll be glad to help you with this. All right, hopefully this video helped you, and you'll get a great grade on this.